So 2013 paper 2 question 1. So you've got Katie tossed a coin 200 times and threw 109 heads. Joe tossed the same coin 400 times and threw 238 heads. Lucy tossed the same coin 500 times and threw 291 heads. Katie, Joe and Lucy now think the coin may be biased. So give a reason why they think that the coin may be biased. So let's see the probability of each one. So the relative frequency or probability. So for Katie, she got 109 out of 200. And Joe got 238 out of 400. And Lucy, she got 291 over 500. So let's see what they all are as a decimal. So 109 over 200 equals SD 0.545. Joe 238 over 400 is 0.595, and Lucy 291 over 500 equals 0.582. Okay, so the reason why they think it's biased is because heads has shown more than 50%. So heads is shown more than 0.5 for each player. So Lucy uses all the above data in coins and calculates that the best estimate of the probability of throwing a head with this coin is 0.58. Show how Lucy might have calculated this probability. So what she could have done is just counted how many times she got heads. So heads between all three of them, 109 add 238 add 291. Oops, 291. That's 638 times the heads appeared out of how many times they tossed the coin. So 200 add 400 add 500. Well, that's just 600, 500, 1100. So probability of heads then 638 over 1100. And that's 0.58. For the next one then, so Joe agrees with Lucy's estimate of 0.58 as the probability of throwing a head with this coin. He claims that the probability of throwing 3 successive heads with this coin is less than the probability of throwing 2 successive tails. So calculate the probability of each event and state whether Joe's claim is true or not. Okay, so you have to find the probability of getting 3 heads. So probability of heads, heads, and heads. So probability of heads is 0.58 by 0.58 by 0.58. Okay, so when you multiply them together, you get 0.195. Okay, and then the probability of getting 2 tails. So 2 tails. So you could have heads, tails, and then tails, but you could have that in any order. So you could have probability of, so let's see. So tails is, if that's 0.58, so 0.58 is less than the probability of throwing 2 successive tails. So sorry, it actually hasn't mentioned anything about tails. It's just over the course of 2 throws. So tails followed by tails. So the probability of getting tails is 0.42 and another tails is 0.42. So when you multiply them together, you get 0.1764. So 0.176, I'm going to keep it as 3 decimal places. So calculate the probability of each event and state whether Joe's claim is true or not. So he said that he claims that the probability of throwing 3 successive heads with this coin is less than getting 2 successive tails. Well, that's false. So Joe is not correct. The probability of 3 heads is higher.